I'm Mr. Marianto. Today, I'm going to talk about mixtures. Now, you might wonder what are mixtures in case you have never heard of them. But before I tell you further, subscribe to support this channel, like this video if you like the video, dislike the video if you dislike the video, and comment down below something if you want to comment down below something about mixtures. Anything else will get removed. So, what are mixtures? They are objects that result in more than one that result in two or more objects simply combining or just mixing, being mixed is mixed. There we go. It's mixed. So yeah, those are technically mixtures. Alloys are technically mixtures. The glass of water that is not pure water, or all of them H2O, those are technically a mixture too. Seawater, a mixture. And a lot more. Steel is a mixture because steel is an alloy between carbon and iron. So yes, it is technically a mixture by the broad definition. And yes, you can separate alloys. Are they chemically bonded to each other? No, you don't need to do a chemical reaction to separate both of two or more substances that are mixed. We don't. How do you separate mixtures? Number one, for fluids that have different weight, I guess, that can float on top of each other. It's decantation. And yes, you can do this with alloys. You simply melt them. I think for fuels easier, I guess. It's carbon after all. It's carbon. So then next one for fluids, that's for fluids. And then for fluids again that are mixed with solid objects is soluble. Pay attention to this insoluble because there is a soluble counterpart. You can use a filter. Filtration. I forgot to input that. Look. Blue buff again. Number 3, for fluids that are mixed with soluble solid objects, you can use evaporation. Number 4, what else? Oh, for liquids again that have different boiling points, you use distillation. How does that work? I need to switch to print mode so I can draw. Yeah, I wonder why didn't they just allow it on, to see what they are. I don't know. Injury race. What's up? It's lag, but in that matter, I guess. Then that is the source of. Let's just put fire there. Just put fire. There, fire. Then that is the condenser. If you don't know, these are supposed to be connected. And yeah, that's essentially it. You can put a container there to get the liquid, whatever the liquid is. So essentially, this is where, well, the mixture starts, and then this is where it was evaporated to. Don't forget the evaporation of, well, boiling. Wait, it will describe different boiling points, but then again, evaporation always goes when the heat, because heat heat is always there. So in here, it's going to cool down. Let me just get to out there. So that's where it's going to cool down. So that's put right there, like here. That's where it's going to cool down, and this is going to where it ends up in the lower uh boiling point will stay. Come on, just okay, just it is. Will stay here, albeit heated, because there's fire underneath. Yep, that's practically it. This one will stay, the other one will go up, then condense. You need to wait until it reaches to your desired container. And then yeah, that's essentially it. Oh yeah, and by the way, it just evaporates here. It's just, well, waiting there, condenses, flows down as droplets. So yeah, I suppose that's it. That's it about distillation. Number 5, for a mixed stack, I guess, stack of metals and non-metals, use a magnet or metals that are attracted to magnets, and those who are not. For a mixed stack of metals and non-metals, or metals that are attracted to magnets and those who aren't, use a magnet. Yeah, you can just use a magnet, and then you need to separate it again. Number 6. No, not there. If you can simply identify which is which, let's just say marbles. Marble inside, I mean not inside, on water, in water, and it is safe to pick up, and not hot, not 100 degrees Celsius. Go on. Yep, that's the simplest one. You simply pick it up. Albeit that does not work for everything, as in, let's say you have a metal that is heated to 100 degrees Celsius on rocks. I do not think that is safe to pick up unless you have the proper safety gloves that is heat resistant. Number 7 for wait, I don't think that is number 7, isn't it? Yeah, that is. I don't think that is number 7. Then again, you could just wonder, hey, is there one of these for color? For color? Yes, there is one of those for color. Number 7, you can put paper, dot it with whatever color of color. So let's see. Color of color. I'm not trying to enforce the debate on which should you use, British English or American English. Color of color. In which both sound similar. And yeah, that's it. Whatever color of color, then dip it in water. The color of color, the colors of colors will separate due to the water coming up. Now this one is kind of difficult. It's chromatography. And the person who invented this, not invented it, discovered it. Well, I could not remember the name, but I could only remember that he was a Russian botanist. And the fact that he is Russian may give you a clue that how I do not remember the name. So yeah, I suppose that is it. We went a little too far, not just by materials, but also to color. I suppose that is it. Thank you for watching and goodbye.